This is the thing that we build in today's video. It is a tamer for metal volcanoes. So like many builds, this is one of the ones where you have to decide what your priorities are while you're building it. Like what are your goals and in what order do they come in? And for me, I decided that the most important thing was access to the metal for my dupes. Regardless of what temperature it is, that's the first priority. And the second priority is for the metal, so that the metal will be cooled down to whatever temperature I prefer that it is. And the last priority is how much power can I make from the heat that comes from the volcano. And I decided that I'm not really interested in making other accessories to go onto the metal volcano, like a petroleum cooker or something like that. And it's because I just don't think that a metal volcano has enough heat to warrant those kind of extra things. So I'm going to give you a tour of this, and then I will use some actual dupes to build the entire thing so that you guys can see what that process was like. I'm just going to show you the route that metal takes from the volcano to the output. So I carry it on conveyor rails. The metal comes out of the iron volcano, and this auto sweeper puts it into this auto loader. From there, it follows this rail, and this rail, it just wraps back and forth, serpentines through this room down here that's full of steam. That way the heat from the metal can go into the steam, and the steam turbine can use it to make power. So from there, it goes into this little heat sink. This little heat sink, its job is to lower the temperature of the metal down to 95 degrees. The reason that works is because the water that comes out of the steam turbine is routed through that metal heat sink. Each piece sits in there for like 5 minutes, so there is plenty of time to get it down to 95 degrees. From there, it gets routed into the same room as the steam turbine. This is the room that is actively cooled by an aqua tuner. I route the metal through this room so that we can cool the metal down to whatever temperature we prefer the metal to be. If you want the iron to come out of the build at 20 degrees, then you can set this to make this room 20 degrees, and the metal will indeed come out of the build at 20 degrees. The metal exits the entire build over here, and there's actually two exits. The first one is across this bridge and into this conveyor receptacle, and that satisfies my first priority. That is to make sure that the metal is available all the time. The second exit is right here. The conveyor rail ends in this conveyor shutoff. The conveyor shutoff uses automation to let through one 20 kilogram piece of metal every 75 seconds. I chose 75 seconds for 20 kilograms because that's the same rate that the volcano makes metal over its entire lifetime. So the build, including the volcano, produces 20 kilograms of metal every 75 seconds at the right temperature all the time. And this satisfies my second priority. So if you're bright, you might be thinking to yourself that thing that I did with the two different exits for the iron is kind of dumb. Well, the reason that you're thinking that is because it is kind of dumb. First of all, duplicants, they don't prioritize like the iron that's on the ground over the iron in the conveyor receptacle. So it just doesn't work at all. Also, there's just an easier way to do it that makes a lot more sense. So the problem that happened is that I recorded this entire video using this way, and I don't want to have to record the entire video all over again. I'll sandbox in the way that I think is better, and you guys can just remember that this is the right way to do it and pretend like you don't notice how bad it is while you watch the video. I'm going to deconstruct these three rails so I can make my serpentine come out a little nicer. I'll replace that insulated tile with a weight plate, that is, and I'll set the weight plate to like however much iron I want to have available for sure to my dupes all the time. I'm going to set it to 200 kilograms. So if it's below 200 kilograms, it turns on the conveyor shutoff like this. Just connect it right there. I can also still do my 20 kilograms per 75 seconds thing. Let's see how that works. That'll just put iron on there until this gets to 200, and that'll turn it off. And now also every 75 seconds I'll drop 20 kilograms, and that's exactly what I want, and that's just the much smarter way to do it. So as you watch the video, pretend that you don't see the dumb thing and just use the smart one instead. Let's look at the plumbing next. So I have a cooling loop in here. If you watch my channel, you'll know that yesterday I posted a video about aquatuner bypasses in cooling loops. This is a cooling loop, this is an aquatuner, and this stuff is the bypass. Unfortunately, my solutions in that video turned out to be wrong. I think they might actually, in fact, be impossible without using some kind of a buffer space. So what we have here is an aquatuner bypass, and I've ended up in this video, in this build, I ended up putting in these two bridges, which is a buffer space for one packet of liquid. This cooling loop is sound and won't ever get stuck. The steam turbine can produce 2 kilograms per second of water. This valve breaks it up into 1 kilogram per second in each of 2 pipes. This allows us to warm up the water in these pipes to any temperature we like without it turning into steam and breaking the pipe. So it's a great coolant for this little heat sink, which cools the metal all the way down to 95 degrees. The reason it's 95 degrees is because that's the temperature of the water that leaves a steam turbine. I think that's essentially a tour of the entire build. You can use the liquid pipe thermosensor down here to control the temperature of the water in the cooling loop. What that means is it also controls the temperature of the iron as it leaves the build. I have this set to 15 degrees, so all of my iron is coming out at 17 degrees, so pretty close. You may have noticed these 4 batteries up here on top. Those don't actually do anything. I was using those for experimental purposes. By the way, this build is self-powered, sort of. The thing is, it produces a lot of extra power while the volcano is active, and it actually consumes some amount of power while the volcano is dormant. It definitely produces more power than it uses, but it still needs to be wired into your grid. Because the dormant period is so long, it really doesn't make sense to store up the extra power that it produces while it's active so that you can use it during the dormant period. The amount of extra power that this generates is something like 100 or 200 watts. So beyond powering itself, it doesn't actually generate a lot of power. Okay, let's build a Volcano Tamer. Let me see. I went to platform above it up here. 1, 2, 3, 4, 5 to hold the steam turbine and to enclose that small heat sink. I'm going to put the steam turbine up there already. I'm going to use my actual dupes to build this as well. So I'm going to put a ladder over here so that they can come up. I need some insulation to go between the steam turbine and my heat sink. I'm just going to use iron tiles for the heat sink part. What else? I need a valve to break up the water that comes from the steam turbine into 2 1 kilogram per second pipes. And I need a pipe. I'll make that out of igneous rock. And I'll make these, I'll make the 1 kilogram per second pipes that go through the heat sink out of iron. I don't want to cover this up anymore yet with insulation and stuff because I want my dupes to be able to get in there and build things. So I'll put it, I can go there. I think they can hop down from there into this room, so that should work out. It looks like I'm missing a bit of that pipe. There we go. I made the liquid valve out of steel. That's completely unnecessary. I'll replace it with a not steel one. Let's start with the auto sweeper. The auto sweeper goes in a weird place. It's sort of at the top of the room in the middle, right over the volcano. Up here at the top, it can reach this entire room. The conveyor loader I'm going to put way over here in the corner. If I start there, it's a lot easier to route the conveyor rail through the whole room the way I want to. We need a thermal aqua tuner. I'm going to flip it around so the input's on the right side. I feel like I'm doing this in so many bits and pieces it's hard to keep track of. So let's focus on one thing at a time. Let's do the cooling loop part. I'm going to put a liquid valve above the aqua tuner to use as a bypass. So that's the way I'm going to stick with for now. Water that I'm using for coolant in the cooling loop will come down this pipe, go into the aqua tuner, or not through the aqua tuner, up through the bypass, and then out this way back up to do its cooling. I want to just fill up this entire room up here with radiant pipes, and that's because I'm going to use it to do a significant bit of cooling. How can I get that? I'll do it this way. And I'll do like that. You know, I made a mistake. I've got to make sure that the things in this room are made of steel. Let me see, the conveyor loader is steel, the aqua tuner is steel, the auto sweeper is steel. I've just got to change the liquid valve to steel. The cooling loop needs automation on it so that it turns off the aqua tuner if the water in it gets sufficiently cold. So I'm going to put a liquid pipe thermosensor right here to test the temperature of the water in the pipe. I want to put a filter gate in here to prevent the aqua tuner from turning on and off really fast. So I'll put a filter gate between the sensor and the aqua tuner, just like that. And there's my automation for the aqua tuner. So I'm going to have to pump the oxygen out of this room because it's a steam room. It's supposed to be full of just steam. Because of the volcano, I can't just fill it in with tiles, so I'm just going to pump it out with a gas pump. I'm going to start setting up that gas pump to do the pumping. But I'm also going to make an airlock so that I can get in and out and set things up. bottle emptier to fill up that airlock with water. That should do the job. So that's all the buildings and hardware that we need in the steam room, except for the rails, the conveyor rails. I'm going to make them out of iron ore. I'm a little worried the first time the volcano erupts, it might melt the conveyor rail because it's definitely more than hot enough to melt iron ore. Um, but I'm going to risk it, and we'll have to see how that turns out. Maybe I'll end up having to fix something. The conveyor rail goes all through the steam room, and that's so that the iron stuff that's on the conveyor rail has a chance to give up its heat to the steam. And then it goes up through this little heat sink, and its only job is to finish cooling down the pieces of iron ore on the rail to about 95 degrees. And from there, it goes into the chamber with the steam turbine. At this point, the iron should be 95 degrees. The only reason we're going in here is because we want to cool down the iron even more. This is the oxygen that we are cooling with the aqua tuner. So it's just like, we'll just use that aqua tuner to cool down the iron. And it's already basically completely set up, so let's use it. And I'll just wrap that. I'll wrap that iron ore all around here. So I'll turn this on so that my dupes start filling that up. Enable auto bottle. Well, this is an interesting problem. So the volcano is going to erupt, and I am totally not ready for it. I should have worked out a way to make that not be an issue. I'll tell you what, let's do it like, This stuff is made out of steel. No, that's good. It's all going to overheat. All right, well, let's just take our medicine. Let's see what happens and try to mitigate the damage. This will be fun. Hey, pause for a second. If you're sharp, you've noticed that I've started doing something up here, but I didn't explain it. Don't worry about that right now. I'm going to talk about it later. So I have a problem over here. I've got a couple of rails that my dupes can't reach, so I'm going to deconstruct this tile. And I think that'll make it so they can reach them. This volcano is erupting, so let's see what kind of horrors come about. There's literally liquid iron pooling here. Anything it touches is doomed. I'm going to tell my dupes to sweep up the iron. And I'm pretty sure I melted... Yeah, the rails behind it got melted. I think they can mop up this stuff. Mop up that iron too, guys. Well, I don't think I've ever mopped up molten iron before. That's a first for me. Okay, that wasn't the end of the world, but let's get this stuff done. I want to get that pump turned on. I'm going to connect everything to external power so that gets started. I'm going to put in a way for my dupes to get down there. Looks like my water lock over here is done, and this room is getting pumped out. I've got to get water in there also. I could pump it in through one of these pipes, I suppose. That stuff is built in, so I can put this metal tile back. And I don't need to be in that room with the steam turbine anymore, so I can close that off. I almost forgot. You really need to put a temp shift plate behind the iron volcano. Like if you just have one right here, that's probably enough. I'm going to put 3 in. I'll use diamond. What the heck? I'm using steel for this build, so diamond isn't such a surprising thing. I've put 3 diamond temp shift plates back there, and the idea is when molten iron comes out of the volcano, the temp shift plates instantly cool it off and transmit all of that heat to the steam that's in this room. And so that when that iron falls down to the floor, it's already a chunk of iron. It's not molten. So I don't have to worry about that problem where molten iron freezes into iron in the same place where a chunk of iron already exists, and so that I lose all of its heat. All right, I'm going to start thinking about getting water into this build. I'm just going to sandbox in some a water source. There's my water pump. supplying water into this. I definitely don't need this bottle emptier anymore. So the next thing to think about is how much water do we want in here? I want 100 kilograms per tile of water, of steam in this room. There's an easy way to do that math. There's 4 tiles in each column, so I need 400 kilograms of water on the floor. 400 kilograms deep all the way across the floor. I'm not sure if the water is going to run out of the room through the airlock, so I just built another tile in here to prevent that from possibly being an issue. I'm going to turn off the input of water. This isn't a vacuum yet. I don't want to flood my gas pump. I'm going to wait for it to become a vacuum in here before I turn the water on. I've got dupes stuck up here on top. They need a ladder to get up and down. And I can build in these insulation tiles. I need to get water into my cooling loop, and I'm just going to use the what's the easy way to do this? I want to use the exhaust from my steam turbine. I just want to bridge it in, just like, something like that. That would be just fine. So I'm going to, what's the easy way to get in there? I'm going to deconstruct these 2 tiles of insulation so that my dupes can get in there and build. Oh, wait. I sandboxed in the bridge. Nah, we can't have that. That's cheating. Now I'm going to deconstruct the bridge and build it again. Okay, great. Now I'll build in those insulation tiles again. There we go. It is taking forever to pump the oxygen out of this room. I guess we could set up our automation and other settings. I'm going to set the conveyor loader to literally take everything because I don't really care what's in this room. I don't want it to stay in there, so I'll send it out. And the liquid pipe thermosensor, all right, here's the cool thing. You can decide what temperature you want your iron to be when it leaves the build, just by setting the temperature on the liquid pipe thermosensor. Want it to be 50 degrees? Set it to 50. Want it to be 20 degrees? Set it to 20. You can't set it to less than 14 degrees because the water will freeze. For the sake of the demo, let's go cold. Let's go 14 degrees. So the volcano is going to erupt. How close are we to being empty here? 500 micrograms. If we can finish vacuuming this out before the volcano erupts, that would be very nice. This sucks because if the volcano erupts, we're going to get a bunch of steam in this room. Oh, I'm screwed. It'll be all right. I'm just going to have to let this thing erupt again. I'm going to turn on the water. I'm going to add water to this until it cools down enough in here that all of this steam turns into water again. There's everything steam in here. Okay, wait a minute. We might be ready to rock. There is no oxygen in this room. It's all steam. So we have succeeded at vacuuming it out. Nothing down here. Nothing down here. Great. All right. Well, that's awesome. I'm going to leave the water on because I need to get water in there, but I don't need the gas pump anymore. Its job is finished. And so I don't need the pipe or the vent either, or the power. Actually, I do need the power. I'm going to leave all of this hooked up to power. So the volcano melted my conveyor rails again. I made other stuff in here out of steel. I'm not sure why I didn't just make it out of steel, but I didn't. Okay, so something's happening. You'll see there's some iron and other things that were down here in this room, and the sweeper picked them up and put them in the loader, and so we're loading up the conveyor rail for the first time. The first time stuff goes out on the conveyor rail, it's going to be a lot hotter than it will normally be while this thing is operating. So like, it looks like we're even getting some overheat damage up here. So that sucks, but I mean, I guess we could open this up, and I'm going to do that. I'll open that up and let my dupes repair that. So the issues to look out for when you fill the rail for the first time is, does the atmosphere that the steam turbine is in get too hot too fast? And the answer is, I really doubt that. Another thing, apparently this liquid valve, since I made it out of copper instead of steel, I'm going to deconstruct that liquid valve, and I think I'm going to make the little space that it lives inside into a vacuum, and that will make it so that it's impossible for it to overheat. I'll see if I can reach in here and deconstruct these 2 tiles. It looks like I can. And I'm going to put the liquid valve right back in there. I'm going to make it out of copper ore again, just to show that it actually is possible for dupes to reach in there and build the valve through the corners. I have to make sure that this valve gets set to 1,000 grams per second. And I sure hope... Okay, yeah, that worked. Now I can build in those insulated tiles. There we go. And now that this valve is in a vacuum, it's impossible for it to overheat. There's no way, there's nothing that can get it hot. Our volcano is done. We don't need to be in this room anymore ever. So let's close it off. All right, remember when I said that I would talk more about this part up here because I didn't explain it when I was building it? This is the time. So all this is the place where the iron leaves the build on the conveyor rail to make it available for dupes. Now what I built up here for doing that is kind of bad. So I'm just going to take that out and build in sort of a better way to do it. In the rest of the video, that better way to do it isn't something that I used, but I didn't want to record the entire video all over again. So just try to ignore the poor way to do it, which is this way, which you shouldn't do. Shouldn't do it. So I'm going to start out by getting rid of all of the things that I dislike. All right, so what we have is, here's our conveyor rail, which carries the iron through the steam room, through this little heat sink, and into our cooling room. And I'm going to finish the serpentine on this on the rail. So the rail serpentines back and forth through the cooling room, and it goes out here. Now, what I want to do is prevent the iron from coming out too quickly. I want the iron to come out of the build very slowly. That way the iron has time to sit on the rail and give up its heat to the steam down here so that I can use it in the heat sink right here so that I can use all of that heat in order to generate power. And also it gives it time to sit in the cooling room up here with the steam turbine until it has plenty of time to cool down into the temperature that you want it to be. So I want to prevent the iron from just coming straight out of the build. I want to stop it and slow it down. I'm going to do that with the conveyor shutoff. In order to get out, the iron has to go through the conveyor shutoff, and the conveyor shutoff will just dump it out using a conveyor chute like this. There are two priorities when it comes to deciding how much iron to take out of the build and how fast. The first priority that I want to satisfy is I want to make sure that my dupes are getting the iron that they need. I don't even care if it's too hot or anything like that. I just want to make sure that there's always iron available. I'm going to deconstruct this insulated tile and replace it with a weight plate. And I'll use the weight plate to determine how much iron is available to my dupes all of the time. I like to use 200 kilograms, so if there is less than 200 kilograms on the weight plate, then I use the weight plate to turn on the conveyor shutoff and let some more iron out of the build. I have another priority when it comes to deciding how much iron to take out of the build. That is, I want to keep the iron in the build for as long as possible. By doing that, I keep the hot iron on this rail down here in the steam for as long as possible. I keep the hot iron in this heat sink for as long as possible. Those things help me get all of the heat out of the iron so that I can turn it all into power. I keep the iron on this rail in the cooling room for as long as possible. And that way I optimize my chances of actually cooling the iron down to the temperature that I want it to be. Of course, you don't want to leave the iron in the build for so long that it starts piling up down here on the floor underneath where the volcano is. That doesn't do you any good. So you want to take the iron out of the build at least as fast as the iron volcano makes the iron, because otherwise it would pile up. But you don't want to take it out any faster than that, because otherwise you're not necessarily taking advantage of the heat and cooling as well as you could. To me, what that means is that it would be ideal if we could take the iron out of the build at exactly the same rate as the iron volcano produces the iron over its entire lifetime. Okay, I got my calculator out. We want to figure out how much iron this volcano makes per second on average for its entire lifetime, because that's how much iron we're going to take out of the build per second on average all the time. So let's start out with the fact that it makes 7.2 kilograms per second while it's erupting. 7.2. Let's have a look at during its eruption period. On average, that means it's erupting for 58 seconds every 910 seconds, just like it says right down here in the details for the iron volcano. You can figure out the average for how much iron it makes during its eruption period very easily from those numbers. You just multiply by 58 and divide by 910. 58 seconds, 910 seconds, multiply by 58, divide by 910. So I did that and I got 0.4589 kilograms per second. What that means is this volcano produces 0.4589 kilograms per second during its eruption period all the time. But I'm not just interested in the eruption period. I'm interested in how much iron per second that this makes on average during its entire lifetime. For me, that means also its active period and while it's dormant. So if we look at the numbers for the active period, 74.2 and 129.1, we can do the exact same thing. Multiply by 74.2, divide by 129.1. So times 74.2 divided by 129.1. Enter. And that tells me that the amount of iron that this volcano produces per second all the time on average is 0.2638 kilograms per second. So that's the number that I needed. That's how much iron that I want to take out of the build per second all the time. Okay, so there's only one more thing we need to figure out. On the conveyor rail, you only get pieces of iron that are 20 kilograms. So I can only drop 20 kilograms at a time off the conveyor rail. So what I need to figure out is how often do I need to take 20 kilograms out of the build in order to equal 0.2638 kilograms per second. The math for that turns out to also be fairly easy. Put in 20 for 20 kilograms, divide by the number of kilograms per second, which is 0.2638. So divided by 0.2638, and we get 75.815 seconds. What that means is if I take 20 kilograms out of the build every 75.815 seconds, then that's exactly the same amount of kilograms per second as if I took 0.2638 kilograms every 1 second. I like to round down a bit, so let's say every 75 seconds exactly. All of that was to figure out that one number, 75. I need to take 20 kilograms of iron out of the build every 75 seconds. So let's set up some automation that turns on the conveyor shut off just long enough to take out 20 kilograms every 75 seconds. In order to turn that on every 75 seconds, I'm going to set up a timer. The way I like to set up a timer is with a buffer gate and a NOT gate. Just like this. If you make them face different directions and then you connect them together with an automation wire like that. Now have a look at what that does. Every time the buffer gate expires, this wire right here, do you see the red one? Every time the buffer gate expires, it flashes green for just a moment. So we can make that flash green every 75 seconds just by setting the buffer gate to 75 seconds. There we go. Now we have a timer that goes off every 75 seconds. Now we want to capture that green flash and use it to make the conveyor shutoff turn on just long enough to let a 20 kilogram chunk of iron through the shutoff. I'm going to do that by putting a buffer gate right here. Now, every 75 seconds, this buffer gate will turn green. I want it to turn green just long enough to let through one chunk of iron. The amount of time that I've been using for that is 0.9 seconds. So I'll set that buffer gate to 0.9 seconds and connect it to the conveyor shutoff. And voila, we have a timer that turns on the conveyor shutoff just long enough to let one chunk of iron through every 75 seconds. That setup will satisfy my second goal, which is to take iron out of the build just fast enough to optimize the processing of the iron for power and for cooling. Since that optimizes the processing of iron for power, that also satisfies my third and last goal, which is to generate as much power as possible from the heat that comes from the volcano. I need to set up the weight plate so that that works properly. I want iron to come out of the build until there's always at least 200 kilograms sitting on top of the weight plate. So if the signal is, if there's less than 200 kilograms, turn on the conveyor shutoff. Let's see how that works. The conveyor shutoff turns on and starts dropping iron onto the weight plate. There. Now there's enough iron on the weight plate, so it turned off the conveyor, shut off. My dupes have access to at least 200 kilograms of iron, and every 75 seconds I'll let through another little chunk. To me, that seems like an extremely optimal way to decide how to take iron out of the build. I'm going to switch back to the footage that I recorded before that had kind of a bad solution for how to do that, which I didn't bother explaining. Just remember that that solution is the bad solution, even though it's on the build that I'm showing you with the old footage. And doing it this way is the good way. Okay, I think the build is all done. So it's erupting right now. Let's talk about what's happening. Molten iron pops up right in here somewhere, and it's in contact with those three temp shift plates behind the volcano. And those temp shift plates are in contact with the water down here. So the water, even though the iron is floating up here in the air, the water is cooling it down very effectively. And it almost instantly gets cool enough to turn solid and turn into a block of iron and fall down into also literally the water. This auto sweeper picks it up, sticks it in the conveyor loader. The conveyor loader puts it on this rail. Now this rail moves very slowly, remember? It moves one space every 75 seconds. So that iron is going to be in this steam room for a long time getting cooled down, a long time. And then after that, it's going to spend, one piece of iron will spend 5 minutes inside these metal blocks while it gets cooled off even more, all the way down to 95 degrees because of the water that's moving through these pipes, which I know it's not moving through those pipes, but it will be once there's steam down here. And then after that, the iron moves into this room, which is actively cooled. I mean, once it's down to 95 degrees, we can't cool it down anymore using a steam turbine. We need another way. And so that's what this aqua tuner, which keeps the steam turbine cool, also cools down anything in this room, including, of course, the oxygen and anything on the conveyor rail. So if we want this, if we want the iron to come out of the build at, say, 20 degrees, we just have to tell the aqua tuner to cool this down until it's 20 degrees. And we do. Actually, what's it set to? Oh yeah, 14 degrees. We're going to cool down the iron all the way to 14 degrees. After it cools down in here, it will go out on this conveyor rail to this conveyor shutoff, and every 75 seconds, one piece of it will just get dropped on the floor. I'm pretty sure that I'm not going to need this water lock, this airlock over here anymore, so I'm going to deconstruct it. Let all the water run down, because I don't care. I do what I want. Okay, so the volcano is going to erupt in a few seconds, and I'm looking at the temperatures, and I see that the water is right on the verge of becoming steam at the moment. I bet all of this becomes steam this time, and I bet the steam turbine starts working as well. The steam isn't going to get hot enough to start generating power, unfortunately. One of the reasons for that is that all of the material that's on the conveyor rail is already cool. The hot stuff is sitting here inside the conveyor loader at 900 degrees, and it's giving up heat. So, I mean, it is going to warm up the steam, but not very quickly. I've got to wait 1.3 cycles for it to erupt again. All right, the volcano is about to erupt again. I'm going to pause this. Have a look. The temperature of the steam has slowly warmed up to 122 degrees in the meantime. So we're like on the verge of making the steam turbine go. And I totally expect that we will be generating a fair bit of power after this eruption is complete. The build will finally be warmed up to the point where it's operating as it's intended. Finally, our steam turbine is starting up. What's cool about that is it's producing water now, so this heat sink over here is getting cooled down. But the eruption is over now. The temperature of the steam in the room right now is 135. This is about what it looks like when it's finally operating, and you'll see that this is producing 350 watts. The aqua tuner doesn't run all the time. I'm pretty sure 350 watts will be sufficient in order to make more power than the aqua tuner uses. On the other hand, when I was experimenting, I also didn't have the temperature turned down all the way to 14 degrees. The more you turn the temperature down, the more energy you use to cool the stuff off. If your power use is a concern to you, then you could always turn this temperature up to the highest that you're willing to tolerate. Okay, the volcano is about to erupt again. Right now, the temperature of the steam is 127. The steam turbine has been running long enough now that these metal tiles are cooled all the way down to 95 degrees, as they should, and the iron on the conveyor rail inside of them is also down to 95 degrees. And if we have a look at the temperature of the iron that's leaving the build, it's, well, we could look at this. It says it's 24 degrees, but I don't feel like that's a good representation. It's out here exchanging heat with the oxygen and stuff. I think it's better to look at iron that's almost ready to leave the build on the rail. And that is down to 16.8 degrees. In the long run, this build definitely produces more power than it uses. But while the volcano is dormant, I'm pretty sure it will use a bit more power than it produces. So even though you could just, like right now, I have this completely disconnected from the external power grid. It's generating all of its own power plus filling these batteries and wasting most of its power. Uh, if I just left this completely disconnected from the external power grid, then eventually when the volcano goes dormant, it won't be able to continue like running the aqua tuner when it needs to in order to cool down iron before it leaves the build, so that your dupes can have it. It will need to consume power during that time. Okay, our volcano is about to erupt again in 51 seconds, but I see that my cooling loop has stopped, and I can't believe it. This is my new bypass. Why would this not work? What has happened? Why? Why? I know to you it looks like nothing happened, but I just took like a 2 hour break from working on this because there's a problem. People who follow my channel probably know that I recently posted a video about flow control for AquaTuner bypass specifically, so that the liquid going through a cooling loop, like the one I'm using in this video, doesn't get stuck as it bypasses the AquaTuner. And I'm using the fancy new one that I figured out, and thought I had everything fixed. And instead, look, my cooling loop is stuck. So I know how to fix this so that it works, and I know why this happened, but I had to take down my video that said, "Here's how to do a AquaTuner bypass." I had to take it down because you know what? It's wrong. Not only was the old one that I was using wrong, but the new one that I'm using is wrong. And after a bunch of discussion with some people that I think are really good, I don't think you can have a bypass that doesn't require some kind of buffer space in the loop. I'm gonna fix this by adding a buffer space in this loop, and it's actually not that hard, and it's not even a big deal. I really want to figure out this problem so that I can show you guys solutions that are really good and always work. All right, let me just show you. Let me just show you the thing that I'm going to use in order to put a buffer space in here. I only need a buffer space that holds 1 packet of water. And the way I do that is, and this I know works for sure. If you just put two bridges over each other like this and you connect their inputs together and their outputs together so the liquids come in this way and they go out that way, then you create a buffer space right there on that pipe, the one that my mouse is on. That space does not get used until this pipe backs up and then 1 packet of liquid will go into that space. And when there is room, um, like if an empty space comes down this pipe, then that packet of water will come out and go to fill up that empty space and go down the pipe. So it's a buffer space for 1 packet of water, and that's all we need in order to make this loop work. So I'm going to build in that double bridge thing right here. Okay, so there's my double bridge, and all it is this is a buffer space to make that work. And so my pipe now goes around that way, and I'm just going to wrap it around in a slightly different orientation there, just like that. And there's my new cooling loop. And this one won't get stuck. All right, there's my cooling loop working properly. And I'm going to have to like get real serious about the science of that AquaTuner bypass and see if there is a solution, or at least work out the simplest way to make it actually work. Now I'll just close that up. And now our metal volcano tamer is done. Alright boys, I think that's it. One metal volcano tamer. I'm still working on a volcano tamer for magma that's like advanced and extensive, that does all of the things. I have some ideas for how I want it to work, and it's starting to settle now. So maybe that shouldn't be too long. Meanwhile, I'll probably post a few videos about small things that are interesting to me. It seems like a lot of new players really like that stuff.